This is just going to be a quick video to walk you through what we want you to do in the evolution activity. You are welcome to just read the activity sheet, and if you know what to do from there, go ahead and start it. This worksheet definitely can just be done individually, but in the past years we found that a lot of people's memories of their evolution background is a little bit shaky, so having others to work with can be useful to jog each other's memories from way back when to freshman biology class, which very likely for many of you was 4 years ago. And similarly, if you have a really good background, it could be useful to help your group mates out a little bit with this. So there's a few parts to this. In part 1, I want you to practice doing a Punnett Square. If it's been a long time since you've done these, you may need to review. You can use the video that I posted in the basic background of your evolution handout. Go to about time point 7 minutes and 15 seconds to get the Punnett Square tutorial. Or just go to any of the 5 bazillion tutorials online for Punnett Squares. I just like the crash course videos myself, as I find the little history points to be amusing and entertaining. Here I choose to do a slightly abnormal disease. Huntington's is autosomal dominant, which means that if you have even one of the mutant genes, you'll have the disease. This is different from most genetic diseases, which tend to be autosomal recessive. Most genetic disorders are recessive, as they tend to cause death or severe illness before reproductive age. So if the person has the disease, they don't reproduce. This means that the gene isn't passed on and won't make it into the gene pool. But if it is recessive, it means that 2 parents could each have a recessive gene and not be sick, passing that recessive gene on to their offspring. The offspring, getting one mutant from each parent, can then wind up sick. But perhaps their siblings just got one mutant copy and is therefore not sick and will go on to pass that disease mutant on. However, in Huntington, symptoms don't appear until after reproductive age, and so people with the Huntington's gene can have the disease, but still have children, thereby keeping the gene in the gene pool, in a way that other genetic diseases which affect people from day one just can't. Here, I ask you to make a Punnett Square for a person who has one parent which is heterozygous, meaning that they have one normal gene and one for Huntington's, and then the other parent which is homozygous for the non-disease causing gene, meaning both of the parents' genes are non-diseasing causing. Then state the odds that this person will have Huntington's. Then I also ask you to state what the odds would be of them having Huntington's if we were instead to say that the gene for Huntington's was recessive, like most genetic disorders. For the next part of the activity, we're going to use a rabbit breeding simulation. When you click on the link, you'll see a slider to start your breeding with a certain number of rabbits. For it to work well, you really need to have it be more than 10. Between 10 and 15 is best. From here, you're going to click Begin. Write down your starting values in the table here and on your worksheet. Then notice this Breed 100 times button. You'll click that 10 times. Each time you click the button, you're saying that there is 100 generations, meaning that by clicking it 10 times, you'll have 1,000 generations of rabbits off your initial 10 to 15 starter population. At this point, record the values in the second line of your table on your worksheet. Continue with the current generation, don't start over. Click the Breed 100 button 10 more times. This is going to be a lot of rabbits. It'll be the expected population after 2,000 generations. Record that value on the third line of your table. Now click on the Start Over. Max out your starting population. Redo the steps you did previously with the clicking of the Breed 100X, recording the values at 1,000 and 2,000 generations. Think and discuss about the differences that you get for the two setups. Why do you think these differences existed? How would this relate to people's evolutionary past? Where might something like this be good? Where might something like this be bad? Follow the directions on the worksheet to cause a forced change in population genetics. You're going to cull the white rabbits. For those not familiar with this language here, culling means killing, but don't worry, they aren't actual rabbits and will simply go off into the virtual rabbit farm to live out their lives happily, but outside of our simulation genetics. Answer the questions on the worksheet about this activity. I'm not going to make another video on this topic, so if you have any questions, please come to class and we'll discuss it there. You can, of course, also watch the class recording to see what other people asked and what was discussed.